So now here's my switch for, here's my keyboard. You know, this is my big key that says 3 on it. My big fat finger comes down and presses it. And what it's going to do, it's going to click that there, and that's going to be now 0 volts. Because remember, our pull-up resistor previously was at +5, but now that that is grounded, that's our 0 volts. And it's going to give me an output for a 3, which what is, if it's active low, what is, what's it going to look like here? And that's my complement of 3, so 3 would ordinarily look like that. Okay, what happens if I press the 3 and the 6 key simultaneously? Well, 6, highest order precedence, you know, that's priority encoding. It's going to produce the complement of 6. What was the complement of 6? We already did this one. So it's 0, 0, 1. And that is the complement of 6. 6 would ordinarily look like that. Okay, so that's the 74-147. Okay, so there's another animal out there called the 74-148, and you think it would be like super high tech because it's like the next model, you know. I don't know if you ever think that way. 74-140, 74-147, 74-148. Well, that's not really true, but anyways, it only has 8 inputs, 8 active low inputs, and whereas previously the 74-147 had 10 inputs, well, you're like, well, this is a piece of junk because it only has 8 inputs. But it's got some special connections that allows you to use it in conjunction with other 74-148 chips in a master-slave relationship. So that way you can expand your number of inputs to however many you want to. So I'll go ahead and draw this 74-148, what that looks like. And this is what a 74-148 looks like. Here you've got your 8 active low inputs, which was very similar to what we saw up here in the 74-147, or if you wanted to set it up in a keyboard combination, just use a pull-up resistor to that individual pin and then means of shorting it to ground. And then we've got right here is our complement, our 3-bit complement, because remember, you can represent 0 to 7 using only 3 bits, so you don't need that 4th bit there. So those are our outputs, 3 active low outputs. But now you see these EI, EO, and GS. So EI is enable input. That's all it does, is it just activates the device. And because it's got an active low indicator on it, a 0 volts will enable the device. That's pretty simple there. But now an EO, what does the EO do? Well, that is enable output. Basically, when it's when this particular chip that we're talking about here, it's receiving one of these active low inputs there, this EO goes high. Okay, so what that means is if I sent that EO signal to another 74-148's chip EI, so basically that enable out is being fed to another chip's enable in, it's saying shut up. Basically, this is the master, this is the slave. Okay, when the master has this enable output, basically when it says 1 on the enable output, it's going to tell anything that it's hooked up to its enable in, silence, because GS, I'm talking. Because you got to figure out who's talking in this whole relationship here. So anytime that GS is 0 volts, it means this is the chip that's talking. Now, here, I'll just go ahead and I'm going to draw a little bit simpler diagram here. And here we go. Here's 74-148s, 2 of them hooked up left and right. And the guy on the left is the master. So its EO is going to the EI of the slave. Okay, so now what's happening here, let's say there's some valid low input. a 0 volts is coming in here. This GS is going to say 0 volts. Hey, I'm talking, the master's talking, and this this EO is going to go high and basically disabling our slave. So this is disabled, and our GS right here is going to be 1, saying I'm not talking. Now, let's say there is no input to the master. One second, let me get rid of all these guys. No input to the master. So it's saying, well, I'm not talking, 1 volt. You may speak, 0 volts. Because this is implying too, by the way, that the master has always been enabled with 0 volts there. So it's sending a 0 volt signal to the slave's enable input. And let's say the slave is now getting a valid low input. What it's going to do is the GS here, because it's active low output, it's going to say 0 volts, I'm talking, and this 3-bit code right here, whatever it is coming out, that's valid. Okay, but now check this out. No information is being sent to the master, no information is being sent to the slave. Same situation here regarding the master. It says enable output, it's sending a 0 volts to the enable input. It says GS1, I'm not talking. Slave, no input here. What's going to happen? GS is going to go to 1. I'm not talking either. Okay, so same thing with a 74-147. To get an active low input, just use a setup, a keyboard setup like that. Alrighty, I think that is about it for encoders. And I think we're going to move on to code converters next.